Before we talk about or discuss anything about a planetary motion, we need to understand the word ellipse. See, first thing is we can talk about the circle. So circle is bunch of points, and yeah. So this bunch of points, everything is bunch of points, honestly. Even this is a bunch of points. But this bunch of points, they follow a rule. So what is that rule? All points are equidistant from a common point. So in this case, I'll call it as O. That's your circle. Now, what we have is ellipse. Like ellipse, here too we have, of course, a definite structure, right? Definite condition, definite rule. So we have a rule that we should follow. What is that rule? Here we are fixing 2 points, and I'm calling it as F1 and I'm calling it as F2. And then the rule is the following. I take up a point, any point on this line, right? Like say here I'll call it as point P. And if I add F1P plus F2P, it always will be a constant. Of course, like radius, how the radius can change, this constant also can change. So basically here the condition is, if I call this as, which I have called it as O and P. So OP is constant, right? And of course this constant can change. This constant can change for different cases. For a given case, this is constant. For a given case, this is constant. Okay, so that's the rule. Rule being what? If I have these 2 points, any 2 random points, and if I take up any other random point which is not along this line, and if I connect a thread, and if I go around this set of points, I get a shape, and that is your ellipse. That's the most basic way to define it. So if I pick up any point on the ellipse, right, measure its distance from each of the focus and take the sum, it will always be the same. So basically this single rule defines a given ellipse. So now, depending on how far apart the focuses are, your shape will change. For example, see here is a simulation wherein I can change the distance between the focus. So now the focus is increasing, now the focus is decreasing. If I go to the least value, it becomes a circle. If I increase the distance between them, it elongates. Can you see that? It elongates. Okay, so it elongates. So if the focus are far apart, the ellipse is longer and narrower, right? So basically, if you have the focus to be far apart, it is going to be stretched. So along with this, we need to know a few more things about the ellipse. That is, one is your major axis and semi-major axis and semi-minor axis. Semi-major axis is the longest radius. So this is the longest, and semi-minor axis, shortest radius. Let me actually make it very clear. I'm not. Alright. Sorry. So something like this, a line which is passing through this to focus. Oh, I got it. And something in the center. So this would be your semi-major axis. And this would be your semi-minor axis. Okay, it's quite simple. And then what else do we know? There's something called as eccentricity. Okay, so here you can see that, right? Eccentricity E. So there is a mathematical relationship that I'll show you guys. ABC, A is your semi-major axis, semi-minor axis, focal distance. So focal distance I have not shown. Eccentricity is a numerical relationship per se, and flattening is again a mathematical or expression basically. So eccentricity, if it increases, as you can see, what happens? What's happening? Now I'm decreasing it. What is happening? And when it becomes 0, see what happens? Yes, when E becomes 0, it becomes a circle. When E increases, it stretches. And E lies between 0 and 1, including 0, that is. So E is maximum, means it is stretched to the maximum. Okay, so if I show you guys the mathematical relationship, it will make sense. So that is your basic structure. Then mathematically what we have here is, so this is your set of points. So this would be x square by a square plus y square by b square is equal to 1. So this would be, this distance is your a comma 0, 0 comma b. So basically from this center to this point, this being the origin, that's your a and this is your b. And x and y are coordinates. So this is x and y. So basically ellipse follows this particular equation. So this is known as equation of an ellipse with the center at the origin. Center not at the origin, all of that comes in your math. So you have a separate chapter for this. So that is, I think, last but one or last chapter. And there's something called as focal distance. So from here till here, or the other way around also, even this. So that is something called as C, focal distance, that we can figure out with, or I can write this, C square of the focal distance is equal to a square minus b square. Again, there's no proof for you guys over here. You just have to know it. So these are all the math that you can get out of this structure. And of course, E. E is nothing but C by A. C is a value which is obviously less than A, right? C is a value which is obviously less than A. So C by A is a value between 0 and 1. At 0, you have it to be a circle. Again, it's a, why is it useful? That depends what you're doing with it. So it might feel a bit too vague. Why is that we are defining E? So again, when you use it, it will make more sense. And there's one more word that I want to show. Anyways, I'll show in the presentation. Okay, so it's a small introduction. So let me see if I have not missed any point. Useful facts about ellipse needed for your Kepler's first law. Actually, all the laws. Standard geometrical definition. An ellipse is a set of all points for which the sum of distance to two fixed points is constant. Then we have semi-major and semi-minor axis. A is semi-major axis, long radius from here till here. Oh yeah, I've marked it over here. And semi-minor axis. This is from the origin to the topmost point. In this case, equation of an ellipse with center at the origin. So we have this. Focal distance from the center to the focuses. So we have two focus. As you can see, we have two focus. So these are your focus 1 and you can call it as focus 2. Focal distance is done, distance from the center to the focus. Then what else? Eccentricity, how stretched the ellipse is. And mathematically it's this. So if it's 0, it's circle. It's between, anything between that, it's an ellipse. Higher the E value, more elongated it is. Oh yeah, this is what I missed. Perihelion, ephelion. So you get this in geography also. Oh, I marked it wrong. Oh no, it's correct. Perihelion is the point. Okay, this I have to explain with the focus in mind. So if R minimum is this, R maximum is this, R minimum is your perihelion, maximum is aphelion. This lets you show the planets move closely and further. Okay, this I think I'll show it with when it go to planetary motion. Here it might confuse you guys. So what did we learn? We learned about ellipse. A small introduction that is needed before you learn anything from Kepler's law. So like circle, ellipse too has a certain rule. And in circle, all the points are equal from a given distance, from a given point, sorry. In ellipse, the rule is a bit more complex. So we take two fixed points and we take a particular length away from both of these points. That length, the sum is fixed, right? The distance from F to P plus P to F, the other F, that is constant. And there are other mathematical expressions. So that you will be, and you, if you have studied in your cross section of cone and all of that. I forgot the chapter name. So there's a mathematical chapter. So there you get to learn this about the properties. You do numericals and you shift the centers, so on and so forth. Okay, so I think you can write all of this.